Use of Maths Data Analysis 2014. On to question 4. Now this is to do with the weight charts at the end of the data sheet. First one, we just want the general trend of what happens with weights with respect to age. So I'm going to look at the chart. Okay. Here's your chart, and you can see the general trend is that as age increases, weight is going up and then back down again. This is the same for all the percentiles if you have a look. Okay, so it increases. So our general trend is weight increases with age. Now it gets to a maximum somewhere in the middle of life. Probably for most of them it's round about the 50s. Okay, to a peak around the 50s, so that's for most percentiles, and then decreases with age. So you need both those points. You've got to say it increases up to a maximum point and then decreases for the second mark. Right, so on the weight chart now here, we want to get an estimate for the interquartile range for women aged 25. So look up women aged 25. Now the interquartile range is the upper quartile minus the lower quartile. The upper quartile is 75% of the way through and the lower quartile is 25% of the way through. So looking up the 25 line, we're going to look on the upper quartile along the 75. Going across to the side, you should get that, reading the scale, that's going to be 73 kilograms. The lower quartile, if you go up the 25 line to the 25% line, the 25th percentile, and go across. Okay. Again, we're going to work in kilograms. That's 54 kilograms. So that gives us 19 kilograms for the interquartile range. Right. Part C now says to assume that women aged 25 follow a normal distribution with a mean of 60 and a standard deviation of 12. And here, first of all, we're going to find the percentage of women who weigh less than 75 grams. So, first of all, we need to work out our Z value. We're going to put in the calculator. So that's our value minus our mean divided by the standard deviation. So in this case, our X value is 75. Our mean, we have to read the question, is 60. I'm not using the charts now. And the standard deviation is 12. And that gives me 1.25. Once we've got our 1.25, we need to go into our calculator. Now it did say less than. Okay, so it said less than. So go into stats mode, 1 var, all clear straight away. And we do shift stat. Number 5 is our normal distribution, and this is just P of 1.25 because we want less than, and that gives us the answer there. So the probability that Z is less than 1.25 is 0.89435. Now there's one more thing with this question. They asked for the percentage. So to turn that into percentage, we need to multiply by 100 to get the percentage. So that's 89.435%. That's 89.43 as 3 significant figures. Sorry, 4, not 43. 3 significant figures. So the second part of part C is to calculate the 95th percentile. So this means we want to know what number are 95% here on our diagram if we drew a normal distribution. So for what value of X are 95% of the women below that weight? So here, first of all, we're going to put all the numbers we know in our equation. So Z is the X value we're trying to find minus the mean divided by the standard deviation. Now what we've got to do is find out what Z value is the same as the 95% below, so 0.95. Now this is where you use the tables that you've been given. We're looking inside the table to find the closest number to 95%. If we have a look here, you can see down here we've got a couple of values here which are very close to 95%, and say 0.9505 is the closest. Now reading off the side of the table, that tells us that to have a 95th percentile, our Z value must be 1.65. So 1.65 is the number we're trying to look for, minus 60 divided by 12. Now you can either go straight and solve this in your calculator using the equation solver, or we can rearrange this. So we're trying to get to X, so X, take away 60, divide by 12. So to work back in, we're going to do times 12 plus 60 is going to be the order we're going to do things in. So first of all, we're going to do 1.65 times 12, and that's X take away 60, and then we're going to add 60, so 1.65 times 12 plus 60 will give us our X value, and then I can just go put that in the calculator. 1.65 times 12, add on 60, so 79.8. Okay, so part D, we've got to look at the weight chart now, and we want to find out, do we think it's normally distributed? And we only want to know for women aged 25. So we're looking up the line, sorry about the board, for women aged 25. Now, if you look at women aged 25, you see there's quite a large gap between the 75th and the 95th percentile, but quite a small gap between the 5th and the 25th percentile. Now for normal distribution, we'd expect everything to be symmetrical, so the answer is no, okay, because the distribution doesn't look symmetrical. Okay. The distribution of weights for women aged 25 is not symmetrical, because we expect it to be symmetrical for a normal distribution. You can write some more comparing percentiles if you'd like. The alternative answer is to use what you've worked out, okay, which also helps. Okay, so the answer is no. You worked out according to the normal distribution, so using the normal distribution, the 95th percentile was 79.8 kilograms, but on the chart, so if you look on the chart, the 95th percentile for women of this age is 100. 95th percentile is 100 kilograms. So those two numbers are different, so it can't be normally distributed. You only need one of these answers, not both.